Good day, I'm Maile Madziba. Welcome back to our channel. We're continuing today with our 2017 study guide of our CIR 113. We're looking at example 3.2. It says the formula U equals to 1.08K over CP times rho is valid on condition that K, CP, and rho are in British units, and it can then be used to calculate U in feet per second. It goes further to say rewrite the formula for direct application with units of the SI system and calculate U if K equals to 0.1 watts per meter Kelvin, CP equals to 5.2 kilojoules per kilogram Kelvin. Let me just put a dot here so that it's up here. It shows that it's 5.2, and rho it's 1,200 kilograms per meter cubed. Now, our step one would be that we calculate the units of the constant 1.08. So step 1, calculate the units of the constant 1.08 in British units. So with this said, we can just say from U equals to 1.08K all over CP by rho, we can see that 1.08 equals U CP rho over K when we make 1.08 the subject of the formula. Now with that said, we can just say therefore it's clearly visible that the units of the constant 1.08 are UCP rho over K. Yeah, so we can actually then move further to actually, do the simplification. We can say UCP rho over K can say equals to, and we know the U is actually from this equation in British units is actually in feet per second. We can say feet per second by our CP. We know that it's in BTU per pound degrees Fahrenheit, and our rho we know it's in pound per feet cubed. Now our K we know that it's in BTU per hour degrees Fahrenheit and feet. With that said, we can just move this up here and we will have feet per second by BTU per pound degrees Fahrenheit by pound per feet cubed. Now also by when we move this up here, we just going to flip it and bring the what's underneath up and what's up underneath. So that is another high school mathematics. So with that said, we can just say, let's see what cancels out. We know the BTU falls off, we know the pound falls off, we know the degrees Fahrenheit falls off. Now we have feet cubed here and we have feet and feet, which is feet squared, so which means the 3 will fall off with this 2 and we'll be left with feet. Now with that said, it gives us hour per second feet. That is actually the units of our 1.08. Now moving further, then we go to our step 2. So our step 2, we can easily say step 2 convert 1.08 h second feet into this SI system, excuse my handwriting, the SI system of units, the SI system of units, and calculate the new calculate the new equation of U in SI units, or let me say in SI system of units. I hope it's visible. Sorry, let me say system. Yeah, I think it's clearer now. So that is actually our step 2. So with that said, now on our step 2, we know that we're going to convert the 1.08 h per second feet into the SI system of units. So with that said, then we're going to say 1.08 hour second feet equals to 1.08 hour second feet by 3,600 seconds all over 1 hour. So we're just converting the hour into seconds, and by 1 feet into 0.3048 meters. Let me put the feet properly. Yeah, it's 1 feet. We know that 1 feet is 0.3048 meters. We're just making sure that we're converting the feet into meters. Remember that we're actually converting from British now into SI, and in SI we use meters. So with that said, we can say equals to 12755.91 meter to the exponent 1, or by 1 over meter. So this becomes our new constant. Now it's in SI. So with that said, we can actually remember it's our step 2 says convert this into the system of units and calculate U in SI system of units. Now with this said, we now have a new constant. We can simply say U equals to 12755.91 K over CP rho. So let me just bring the original question. We actually changed the 1.08, we substituted with 12755.91, so which is actually the new constant, and this equation will actually be applicable or valid when you use all the values in the SI system of units. Now, just to explain it much more, we can say, now that we have this, we can say with K in watts per meter Kelvin and Cp in joules per kilogram Kelvin and rho in kilograms per meter cubed. Another important thing I need to highlight is that it's actually joules per kilogram Kelvin. So Cp, this equation works for Cp in joules per kilogram Kelvin. It's important to highlight that because remember our Cp has been given as 5.2 kilojoules per kilogram Kelvin. So this equation takes in this equation actually takes it in joules per kilogram Kelvin. So it's important that one don't make that mistake, because if you punch in 5.2 there, it might not be, well, rather it will be incorrect. It won't give you the right answer. So with that said, let me also just write here, and U is in meters per second. So now we are done with arranging the SI system of units equation, that we can actually plug in all the values in the values given in the SI system of units. So this takes us to our step 3. We can just say step 3, calculate U. Calculate U in SI units. Yeah. Oh no, sorry, in SI units. I hope it's easily visible there. Calculate U in SI units. That's actually our step 3. Now we already have the equation and we have the data. What we need to do now, we can just say Using this equation, we can just go back to the information we are given. Remember, this is actually the information that we have been given, so we can just say u equals to 12755.91 multiplied by our k is 0 0.1 all over our CP is given as 5.2, so we're gonna be putting 5,200 because it's 5.2 kilojoules. We're using joules, so it's 5,200 joules. So multiply by our rho, which is 1,200. Where is it? Oh yeah, here 1,200. It's 1,200, and now it gives us an answer of 0.000204 meters per second. It's very much important that I highlight a very much important principle here is that in as much as we converted from the British equation or the British equation with British system of units into an SI system of units, which is this one here, this is still an empirical equation, which means when you plug in the values, you can't plug in the units on the equation, there'll still be dimensional incorrectness. So there won't be consistency. With that said, even if we have converted it into an SI system of units equation, we still are using the values and not the units. So yeah, that's something that I needed to highlight, and I believe it's clearer. So thank you for your time, and I hope we meet again on our next video.